In the previous video, we've had a look at these 3 points and looked at what a solution is, and how we can have infinitely many solutions, and how one of the two variables is a dependent variable whereas the other is the independent variable. Now let us move further ahead and have a look at another property of such equations. Here we have the same table with all the 3 values of both the two variables. Now let us try and plot these values on a graph. Here we have a graph. Now we know that a graph has 2 axes. This one is the x-axis and this one right here is the y-axis. Now what we can do is we can take one value and plot it on one axis. So let's say we plot x, which represents the number of donuts. On this axis, number of donuts sold. Let us plot this on the x-axis, and let us plot let's say the money earned on the other axis, which is the y-axis. So money earned will be plotted on this axis. Now what is the first value that we have? The first value that we have is 1 for the x-axis, on the x-axis, and 6 on the y-axis. So here I have 5, so this must be 4, 3, 2, 1, right? So that is 1 on the x-axis, and here I have 5, so this must be 6, so that is 6 on the y-axis. And if I draw lines, perpendicular lines from both of them, they kind of meet at this point. So that is my first point right there. And similarly I can do the same thing for the second day also. I have 2 on the x-axis, 8 on the y-axis. This is 2. I draw a line from here, not the best line, but yeah. And this is 6, so this must be 7, that must be 8. So I draw a line from there too, and they intersect somewhere here, so that must be the second point. And similarly I can do the same for the third point. You can verify it yourself by pausing the video. And this is 3 and 10, 3 on the x-axis, 10 on the y-axis. Now if you look at these 3 points carefully, let us just label them. This is 1, 6, 2, 8, 3, 10. You've learned that how we can name these points in the chapter on coordinate geometry. But yeah, if you look at these 3 points carefully, we can notice that all these 3 points lie on a straight line. In fact, I can actually draw a straight line through all these 3 points, and all the 3 points lie on that straight line. Now in the previous video, we've also noticed how we've also learned that how we can have infinitely many solutions to our equation, right? What was our equation? Our equation was y equals 2x plus 4. This was our equation, and all these 3 points are a solution to this equation, right? We've discussed that earlier. Now if you also pay attention to the title of our chapter, it says linear equation in 2 variables. We have 2 variables, y and x, but why is it called linear equation? Well, this is the exact reason why we call it a linear equation, because when we plot all the points, so we just plotted 3 points, 3 solutions of the equation, they all lie on a straight line. Now we've just plotted 3 solutions, but we can go ahead and plot further more solutions, and all of those solutions would lie somewhere on this straight line. So let us come up with another solution of our problem. Let's say Tommy sells 0 donuts. So what does that mean? Tommy has sold no donut on that particular day, which means x has a value of 0. And now our equation becomes y equals 2 times 0 plus 4, and 2 times 0 is 0, and we only have a plus 4, so y is simply 4. That means I have just come up with another solution, 0, 4, right? So when x is 0, y would be 4. So 0 comma 4 must be a solution to this equation. Now what I've just said before this was that all the solutions to this equation lie on that straight line. So because this right here is a solution to this equation, we've just found it out. This point also must lie on this line. So let us just confirm that. Where would 0 comma 4 lie on this Cartesian plane? Well, we have to go 0 on the x-axis, that is 0 on the x-axis, and where is 4? Well, 1 2 3 4. So if we see 0 comma 4 is this point right here, we can label that 0 comma 4, and it turns out even this point lies on the straight line, and we've just verified that all the solutions of this this linear equation y equals 2x plus 4 would lie on this straight line that passes through all the solutions. So that is why this equation is called a linear equation, because when plotted, when all its solutions are plotted on a Cartesian plane, they form a straight line.